And we're live. Welcome, man. How's it going?
Hey guys, thank you so much for having me. It's my second time on here. So nice to be back here.
Yeah, so tell us, yeah, son, you were on seminar like in 2019, you said? What were you presenting then?
So that was around the time I started working on manual seal, which is like this uh, manual consensus algorithm. It's supposed to allow like single node environments. This is an idea I brought from the Parity Ethereum client that we had that I was also working on before transitioning to the Substrate team. And in that client, you could just run a single node environment and it would just author blocks, continuously. You could also like send like an RPC to it to like tell it to author blocks just so you could test transactions out and stuff. So I was
So this is
showing,
just to like a testing tool kind of thing that
yes, it was a testing
to
tool.
testing.
Yeah, single node environments. You could test your transactions, test smart contracts as well.
Cool. And so after that, then you actually worked at Parity for a while. You I don't think we've never while I've been working at Parity, we never really interacted much. But I think that's because you were working on something very specific. Do you want to tell us a bit like what you were doing at Parity before?
Yeah, I mean, I did a lot of stuff to be honest. I spent time with the client team. We did a lot of like refactorings and stuff. But towards the end of my time at Parity, I was working on this idea that Tomek had, which was that we should be able to have like a sort of environment where it's a full node, but like you have control over block production through manual seal, of course. And then you could also like submit transactions directly into the transaction pool. And you should also be able to inspect states, like your palette states, right? As these transactions change the storage of your runtime. So that's what I took, primarily for Polkadot, actually, not for parachains. So it was merged eventually into Polkadot and the Substrate repo, and then used to test like runtime upgrades for Polkadot. But as you all know, this session is actually for parachains, and we'll look into how that works with parachains.
Cool. Yeah, awesome. So, as per typical seminar sort of protocol, feel free to ask questions, guys. I invited like some folks from some Parachain Builder teams here. Hopefully, they're gonna have some questions because I think this is a super interesting tool. I haven't seen it being integrated in the CI of any team apart from composable finance, which by the way you didn't really talk about. So like we talked about what you're doing, what you were doing before, and right now, what are you working on?
So right now, I lead the Substrate team at Composable Finance. It's not an easy job. I've bricked the network twice now, and like that's like so far. But it's fun, and I get to work on like tools I already love, Substrate, Rust blockchains. So yeah, that's what I do right now.
So you're a core Rust developer working on sort of just building the team and the efforts of Substrate developers for composable finance.
Essentially, yeah. As well as like bridging stuff you've seen. I don't know if you guys have seen our announcements to bridge the IBC and Polkadot ecosystems, also leading the efforts there, working with the Bridges team at Parity as well.
Sweet, super cool. Yeah, so for everyone watching, this refers to so composable finance is the team that is building the well right now the Picasso uh, uh, parachain on Kusama is live, and I believe that's what you were mentioning was bricked. You were having a stressful week last week, I think.
Yeah, it's crazy. It's crazy. But luckily, because of the design of Polkadot, it was easily recoverable, and that's great. It's great for everyone.
Sweet. Yeah, I guess that so today we're kind of going to touch on like your experience with that and why you built Simnode and what Simnode really is for, right? And like how it can be useful for teams like that are going to run into these types of issues where there's always going to maybe be an error, and how can we catch these errors and write tests before going even to a live test net. So I'm hoping that we can touch on these things and kind of bring back to like the reality of like there's like for any team, we're going to have similar types of problems, and how do we address these with like good CI and like testing tools and mechanisms. So I don't know exactly what you had planned for this session, but it would be super cool like to just first of all go through what Simnode is, the motivations behind it, and and we can like see a little demo.
Yeah, nice. That sounds good. So I guess we can start with what Simnode is in general. So I said Tomek initially had the idea. He wanted us to be able to author blocks and put transactions into the transaction pool and sort of watch how transactions mutate state, all in like from a Rust test, right? That was the whole idea. You'd spawn all the node subsystems and all. We eventually achieved that for the Polkadot repo, but during my time at Composable, I realized that like there was no such thing for parachain runtimes, and parachains are especially complex because they kind of need to interact with a relay chain. As you know, if you want to like test transactions, you have to spawn. You have to use Polkadot Launch. I know all of us here are familiar with Polkadot Launch, and essentially spawn this relay chain and a parachain. You probably don't need to do all this. You just probably want to mock some systems on your node that allows you to create blocks, allows you to apply transactions to state, also allows you to like resume a live database. Say you already have a live chain, maybe your testnets, maybe your mainnets. You should be able to experiment with what transactions would do to this state and how like state would change. This is useful for runtime upgrades as well as runtime migrations. So to be honest with you, before Picasso went live, I had massive anxiety. We don't actually have any like useful testing tools for this. And so that's around the time I started hacking on it so that I could make it work for parachains. And yeah, we can actually like quickly do a tour of what tests look like for this, how to set it up. There are examples in the repo, and maybe I can share my screen and we can follow along.
Yeah, sure. And while you're setting that up, I think this is a cool opportunity to touch on very like let's be explicit on like when you're building a parachain, you will kind of build a node locally, and then there's like certain steps to take to then even connecting to a testnet or creating your own testnet, and then from kind of being happy with the results from connecting to your own testnet, you're then connecting to some like more real world like test networks such as Rococo, or even just connecting to Kusama if that's the plan. So like, what are these steps? Like, can you step us through like the typical journey from starting just completely locally with your own environment, no collators, nothing, to then becoming or at least having the testing frameworks to connect to a relay chain?
I mean, I'll definitely say you start from Polkadot Launch. Once you're done with Polkadot Launch, you can then sort of use Simnode to sort of run the simulation of really any amount of time in the future, just so you assert that your runtime will not produce any panics. If you're good with that, then you could deploy to Rococo, you could deploy to even Kusama at this point, because you're very sure that your runtime won't misbehave, given the current code.
Yeah, so cool. So to be clear, it's like we're talking about that stage where you're using Polkadot Launch, you have your own kind of local testnet, and we're just running tests on a simulated environment. And what do we mean by simulated environment? Can you touch on that?
Yeah. So I mean, Simnode mocks a lot of like subsystems in Substrate just so that it could work. We'll start with the fundamentals, which is the consensus layer. As you know, parachains use Aura. And the gist of how that works is that there's some task running on the node that is producing digests, if you're familiar with that. It's placing that into the header, and then your runtime, which expects these digests, will check to see if these digests are valid, and then of course then your blocks get processed. So in order to sort of produce these digests, we have these consensus data providers. There's an implementation for Babe. The one for Aura was recently merged, and that's why it can now work for parachains. So that's one layer of mocks. There's another layer, which is the signature verifications. Your runtime doesn't actually embed the code for verifying signatures. It actually delegates that to like a host function. outside of your node. And so Simnode is able to hook into that and sort of prevent your node from verifying signatures. This is useful for if you're trying to author transactions for any accounts, which is often what you want to do with like a live chain state where you have like authorities and you want to see if they could cause maybe any potential issues with your runtime. And that's basically most of it, to be honest. The rest of the subsystems work as normal: the transaction pool, the runtime executor, even your database, to be honest.
Cool. So yeah, we're literally like creating a node that has like these extra like functionalities that you can just play a little more with how blocks are being produced and executed.
Basically, yeah. And that's powerful because you can then like test out transactions from a full node state that you probably wouldn't be able to do on your live chain state.
Super
so
cool. Yeah.
I would love to like sort of step through how you would set this up for your parachain runtime. I don't know.
Yeah. Do you want to share your screen? So if you hover over your image, then you'll see a share screen button.
Okay. Yeah, I see it. Entire screen. Allow. This is where I ask, can everyone see my screen?
Yeah, everyone can see your screen. Oh, I can see your screen, so I'm pretty sure that means everyone can see your screen. Yeah, so just I'll interrupt one more time. Like, there's a question box. Ask your questions in the question box. This seminar, I think, is really meant to like engage with people that are curious about how they could be setting up Simnode in their own environments for their own CI. I think it could be a super useful tool for so many teams, and maybe also some of you watching right now have ideas and things that they want to share in relation to what we're going through. So don't be shy. Yeah, we're here.
Nice. So let me quickly step through what this looks like for parachain runtime, and then we can look at the CI
zoom just a tiny bit,
okay,
so that we can. I just have it. Yeah, perfect.
Maybe one more.
That's good.
So you notice that this is like a main.rs, meaning that this is actually a binary, in that Simnode is a full node on its own, but like instead of just doing the usual things your node will do, which is just listening to transactions on the transaction pool and just author blocks or just follow consensus in general, your node is entirely controlled by what you do. And we'll look at those APIs in a second. Just look at the quick setup. This stuff you're already familiar with it from setting up your service file. You will note the signature verification override host function that's been added here. This enables for you to author extrinsics that are valid for any account. And then we have a sort of CLI config. This also enables, just so for us to have like much easier APIs for running your node. Where we use a CLI here because, like I said, it's a full node. You want to be able to pass all the usual CLI arguments you would pass to your normal node. Of course, setting maybe a base path here to an existing database. So this is sort of where the core of Simnode stems from. You have to define your block type, the execution dispatch. This is where you specify your runtime and runtime APIs. Select chain implementation. This is usually just going to be longest chain for all parachain runtimes, unless you're doing something fancy on your consensus layer. For block imports, you just use your clients. For signed extras, you also use the signed extra you've defined in your runtime. For inherent data providers, this is where it gets tricky. You have to pull in slot timestamp provider, which is a lot like the original timestamp provider, but instead of checking your system time and then putting that into a block, it will calculate what your next slot should be based on your slot duration and the previous slot. So that's this just allows you to be able to author blocks like sequentially without waiting that period of time, the minimum duration in between blocks for the pallet timestamp. This is standard, the Aura provider. And this is also something that Simnode introduces. As you know, parachains actually need to have this inherent that comes from parachain system. But we mock that inherent, and that's what allows us to create blocks that are valid for parachain runtimes.
So just on the note of inheritance, I don't know if everyone is very familiar with what an inherent is, but basically, and correct me if this is maybe not the definition you have in mind, but these inherents are everything that like the node needs from like basically to author blocks and to author or to verify, validate the consensus mechanism happening between the parachain and the collators from the relay chain.
Exactly.
So they're a special type of extrinsic, really. In Substrate, we call sort of any type of transaction, unsigned or unsigned, as an extrinsic. But there's also sort of this third type, which is an inherent. So the inherents are like really that piece where it's like you can think of it as a transaction that only happens within the node. Cool.
Right.
So that just wanted to clarify that because I'm not sure if everyone was familiar with what we were looking at. Let's proceed.
Nice. So this is also like where we set up our extras, signed extras. The reason we do this is because the node needs to know how to like create the extras to be included in any transactions that you create with the node. So this function also, will be executed in an externalities provided environments. For those of you who have worked with like test externalities, and you know how like you might want to read storage values from a runtime, you can do that in this function if you need to include any storage values from a runtime in there. And so we arrive at like really the gist of Simnode in that like you run this simple function, you have to provide it a callback, and it gives you a node. And with this node, you can submit extrinsics, any kind of extrinsics. You just create them and you submit them, given the public key of an account. So this extrinsic will be executed as if it came from this account. It could be a pseudo key. It could be, like I said, a privileged account that's already on chain, exists in your live chain state. And you can simulate what this transaction would do, as if it was authored by this person. The second key API is the seal blocks. And you can actually pass any number of blocks here. Perhaps you want to wait after a democracy period. Perhaps you want to trigger some uninitialized calls in the future. This is where you can do all that. And then lastly, you can also read from state. You can inspect your palette state. And you can just this is an externalities provided environment once again, and you can just call any storage function from your runtime.
So it's the second time you're mentioning. Sorry, it's the second time you're mentioning externalities environment. Can you describe what that really is on a Substrate node?
So to understand externalities, you have to first of all understand how Substrate executes your runtime. I mean, in your palettes, you define types. You say, okay, I want to have a storage value. You define its defaults. Methods. You also define how it gets put from your genesis state into that value. But at the end of the day, all of that is going to be executed by sort of like a host function, right? And this host function is actually what provides your runtime access to underlying database storage, which actually is a try, but you don't need to think about that. All you just think about is a type and how to get this type and how to put values into this type.
Mm-hmm. So when you say externalities, you mean basically it's that storage layer?
Essentially, yeah. It's a storage layer that allows you to write values into your runtime, into your palettes, into your blockchain state, technically.
Cool.
So as you can see, in this, you can actually read the events that are stored at frame system, and you can print them out. You can inspect them, what just happened, just check what just happened in your runtime. So I would also like for us to quickly look at how Composable Finance uses Simnode to test things like runtime upgrades, also to test stuff that can break our chain. So let's look at the runtime upgrade test. This function is made to be generic. So don't worry about all this stuff. It's just so that whatever runtime we have, we can run this test on that runtime. I also imagine that if people start to adopt this library more, we can start to write tests for palettes that are generic over the runtime, and we can all share these tests and run them as part of our CI, just to ensure that like these palettes still work correctly, e.g. after a runtime upgrade.
That would be super cool. Yeah. Like, all these palettes that lots of parachains use, they have a lot of commonalities. I mean, a lot of parachains use palettes that are common to like others, and like it would be so cool to have like sort of a library of tests that everyone can use based on like this.
Exactly. It will definitely help the parachain testing story. So just to quickly look at the test for executing a runtime upgrade in Simnode. Here we read the state of the blockchain. We're actually looking at the pseudo palette and trying to pull out the key, just so that we have the public key of the pseudo accounts. Using the client, we can actually read the runtime version at a specific block height. So the client is actually like used all over, and I feel like it's poorly documented, but it's actually really powerful to learn how to use the client. It's used in your RPC layer, it's used in the consensus layer, it's used in the transaction pool. So it allows you to do cool stuff like this. You can pull out the runtime version. You can also do other cool stuff like reverting blocks as well. You can do that with the clients. So we now have the old runtime version here. Here next, we should just construct a call saying, hey, we want to author a transaction with sudo, and have that be the call to frame system set code. And then we submit that transaction using the sudo account. If we had submitted this transaction with any other accounts, your runtime would actually bounce this transaction, because in your runtime, like any other account doesn't have the permission to execute this call. But if you seal a block, it will actually include the block and execute it properly. Now, this is where we use the parachain inheritance, in that, so how the relay chain tells your parachain to upgrade is by including an inheritance, that your collators eventually pick up and then feed that into a block. And we can just mock that here just by saying, hey, we lie to our node, essentially saying we have the upgrade go ahead signal from the relay chain. So that's now an inheritance. And then we can author a block with that inheritance, and our runtime will just believe that and essentially apply the validation function, the new WASM code. And so we can just check now the runtime version at this new block height and assert that it was it's bigger than the old one. And it means that we've indeed upgraded our runtime. And so you can then do anything from here on. You can then inspect states. Maybe you expected a migration to happen. You could then quickly use Node with states to inspect that these migrations did happen correctly.
Cool. There's a question that we could maybe answer now, which is Simnode specific to a consensus mechanism, or does it support any?
Yes, so it's not specific. It's actually made to be generic over whatever consensus mechanism you're using. So actually, let's quickly look at how that happens in Substrate. So Simnode uses manual seal in order to author blocks. And manual seal also exposes this API called Consensus Data Provider, which we now have implementations for Babe and Aura. And this is really how you can then allow Simnode to be able to author blocks that are valid for your own specific consensus worker or consensus mechanism, just by having, creating the proper digest that will then be included in the header of your block. You can quickly look at the implementation for Aura. I think Aura is pretty simple enough. I see right here. So it will just check the timestamp inheritance, and given the timestamp inheritance, we want to divide that by the slot duration, which is now the slot number of this block, and include that in the digests.
Cool.
So I
So
wanted
the
to,
answer is so long as it's implementing that manual seal mechanism, then you could use any
yes,
type of consensus mechanism.
yes, yes. There's also an implementation for Babe as well. Babe is a bit more complex, but yeah, it can work for any consensus mechanism, given that you're able to implement that interface. So
There's another question that came up, which is, would Simnode be able to run on top of an arbitrary chain state? This would allow testing things like runtime upgrades on the forked state of a live chain.
yes,
So
actually, I'm about to show what that looks like, in fact.
awesome. Yeah, so I think that the
So
answer is like yes, this is exactly what Simnode
what it
is
was built
basically.
for.
Yeah,
Yeah, that was what it was built for.
like we could be
Um,
testing on like how I think about it is like, you know, when you're authoring blocks, you're, you know, there's potential like forks that could be valid, but only one is chosen sort of to be the canonical. You can actually like simulate, or you can actually be writing tests on these different forks ultimately, and then, you know, not only the one that becomes a canonical chain. Is that like, is that correct even?
I mean, you could, if you're able to like download the blocks at that fork height, then you can feed that into a Simnode and run over that data.
Right. Cool. Yeah. So I guess, I mean, the clear way to see it is you can, the whole point is that you can run on any arbitrary chain state, and you know, don't necessarily need to sort of do what I was just described, but Simnode does give these kind of like very generic capabilities you can kind of write a lot of different testing cases for.
Exactly, exactly. I think what would another interesting test case for Simnode. Oh, let's get to that. Let's get to that in a minute. Let's look at the how we at Composable Finance use Simnode to like test our runtime changes. So we have a CI pipeline in on our GitHub where we check on every PR to see if PR has modified files that under the folder where we store, say, our palettes or the known runtime files. And so if we spot a PR that does this, we immediately download a nightly snapshot of our database of the chain that this change is being made to. It could be Picasso, it could be DALI, which is our testnet, it could be the composable parachain on Polkadot. And you just download this. It's a zipped file. It's essentially a zip file of our base path. And so we just unzip that file and run Simnode with that base path. And that's all it does. And so Simnode is essentially trying to like execute a runtime upgrade with this, given this chain state, and this new changed WASM file, which it uses to build like a new runtime WASM. So we can actually look at how DALI uses this runtime upgrade test. Maybe not DALI. I think Picasso is more interesting because we had an issue on Picasso, and this is what I wanted to show. So in the run function, because it's a node, by the way, we just, first of all, this is unimportant, but we just pull the WASM binary. As all runtime developers would know, you can access the raw bytes of your WASM binary through this variable. That is, if you enable that build to happen. And so given that code, you can just pass it to the function to upgrade the runtime, and that will happen in the background. And then you can also do something cool like checking ahead of time to see that like all the blocks in the future will not panic your runtime. There will be no uninitialized calls that will get triggered and that will panic your runtime, which is the issue that we had on Picasso last time. Was when I upgraded the runtime to 0.11 from 0.10, and there were some new calls that had been introduced to democracy, to pilot democracy, and because I couldn't I didn't want to run the benchmarks. I just put a to do there, harmless. I pushed that to GitHub, but somehow it got merged and it made its way into a production release that was running on Picasso on Kusama. And essentially 7 days after the chain starts, there will be a new launch period, which is like where like referenda gets passed and stuff. So in this launch period, in the uninitialized call of pallet democracy, we're going to do some weight calculation using these values that I had added a to-do in. And so that was doomed to panic, right? If we had Simnode, we would have been able to simulate ahead of time all the blocks that could have triggered any of these panics in their uninitialized calls. And so that's what this is for.
Right, because that call wasn't going to be made sort of under normal like circumstances, if you had users just kind of normally interacting with your chain, because it was within the uninitialized function, which would have only been called from a democracy origin, which happened, but like there was no test for that. And
you can't even write a test for that, actually.
What? So actually, that's interesting. Why wouldn't you be able to write a test for that? And how does Simnode really catch that? I think I kind of understand that it catches it by really running the chain like for a long period of time, at which it will have kind of passed that 7-day period. But then how does it pass the 7-day period? How does it catch that?
So I mean, Sealbox uses manual seal in the background, right? And so when you make a call to Sealbox, you're telling manual seal to author this many blocks. It doesn't actually take time because the blocks will be authored like consecutively, immediately. The minute it authors one block, it moves to the next until like it is past the number of blocks you asked it to do. So in those blocks, you're essentially advancing your chain state. You're lying to your chain that like this actual amount of time has passed. You're lying to your minimum period, for instance, with pallet timestamp. So if you had any sort of functionality that hooked into pallet timestamp, that depends on some future time or some future timestamp, you would be able to trigger those calls in a much shorter period. You don't have to actually wait for that to happen on chain. So like I said, this call to Sealbox really is all we need to like simulate all these blocks on our state and see what panics happen, if any. So I also wanted to show how like it's useful to be able to simulate transactions using Simnode, because we also had another issue with our Parity on Picasso when we were trying to fix the first postmortem. So what we had inadvertently in the rush put a wrong para ID into our Genesis states. That's the chain spec. So that was the wrong para ID, right? And what that essentially means for a parachain with a wrong para ID in storage is that you can't do runtime upgrades. You can't do XCM because that stuff is used by the relay chain. So here we can simulate a call to mutate the state at a specific pallet, which is in this case parachain info. Parachain info stores your para ID and it loads that value at Genesis, but it doesn't give you any calls to change that value. So what you could do with Simnode is you could actually get the actual key to that value in your try, and then using frame system set storage, you could simulate if this transaction would indeed mutate parachain info and set this new value. And you can essentially assert that this new value has been set by looking at storage. So in this case, we create the transaction here using sudo as usual. We set the key. Key was derived given this call. Parachain ID is actually private, so I had to make it public just so I could get the storage key for this. And then, of course, you have to hex encode your values, which is our actual para ID. And then I could simulate this transaction, submit an extrinsic, seal a block, check state that this transaction has mutated my state in the way that I expect it to.
Okay, that is like super cool, I think, and super useful. So kind of stepping through what you just went through is basically like verifying that the parachain ID is the
The
parachain
wrong
ID that
one.
is yeah, well, yeah. So basically, like the scenario would be that the relay chain has a registered parachain ID, and when you want to connect with it, i.e., you're connecting your parachain to this relay chain, the parachain's like runtime needs to have the same matching parachain ID. Otherwise, the relay chain will just like reject it, and it won't work. And you might, I actually know several people that have come to this problem where like they just can't figure out why it's not working. So this test is basically just checking for that, and it's a way to say, okay, the same power ID is present that has been inserted in the parachain's chain spec, I guess, right?
Essentially, yeah.
So wait, so how does that sort of how do you get that parachain ID value originally? Like you said, you had to make it public. What did you mean by that?
So this is a module, parachain info, palette parachain info. It comes from Cumulus, and it has like a storage value, parachain ID, right? But that storage value is actually private. It's not public. You can like pull that information from another module. So I just had to go
Mm-hmm.
into that palette, sort of modify it, run a test saying console log, your storage key, just so that I can then
Right.
use that to call frame system set storage. And of course, I can call in this with sudo, gotten from the runtime,
Right.
just so that I can execute this call.
Makes it easier, yeah, for sure. Super cool, yeah. I think that's a
So
very valuable test.
yeah. And we had to actually test this, run the simulation before actually executing it on our parachain, just so that we're sure that it doesn't really damage our runtime in any way or trigger any unexpected behaviors.
Really cool. So there's a couple questions I guess we could answer. Where are the staking parameters defined, like inflation of the parachain? That is an interesting question. It's not very relevant to like Simnode and using Simnode, but I guess the short answer is it's well. Actually, do you want to? Can we pull up where that's happening?
The staking parameters, I mean, it's just going to use the same, like it's still your parachain runtime. It's not introducing, Simnode is not introducing its own runtime. It's just running on top of your own. So everything that you've defined will stay the same. All your runtime constants will stay the same.
Yeah. Yeah, there is a there I can try to share a link on specifically that to answer that question, but for Simnode, it doesn't care, right? It's whatever's in your runtime. And like typically like runtimes built with Frame like have their own sort of like mechanisms like like fees and like transaction fees and like how like inflation works and all that stuff. But that's something that you can kind of modify in your runtime. But I will try to find the proper answer to that by linking to where it happens. The other question that we had is, I wasn't too sure about what you're asking, Diego. The question is forkless updates, is a forkless update implemented? And if yes, like what are the steps to achieving finality? And I'm assuming you mean like how does testing a runtime upgrade work in Simnode?
I mean, I feel like we just shared that process,
Yeah,
though. Maybe this was earlier.
exactly. So I'm curious in kind of just knowing about like the types of tests that you want to write more. Like what are you thinking? Like now that Simnode is you're using it for very specific things, and I guess like you're also gonna use it as problems come, how to fix those problems. But is there a way to kind of get oversight and write tests that like that are going to be checking things that are crucial?
Honestly, I would say palette tests for all the palettes currently in the Substrate runtime, test for balances, democracy, especially these palettes, they change very often. They have like migrations associated with them. We've seen cases where these palettes actually had, bad migrations written for them. And so I think these foundational standard palettes would do well with like having Simnode tests. just so that, once we test the runtime migration, we can also just execute this suite of tests for all these palettes. Do they all still, behave as expected?
Super cool. Yeah, well, I mean, I don't know. I think that this tool is like, we went through the tool, we demoed it. In the end, like, that's the rest is really the types of tests that you're going to be writing, and how you're integrating it into your CI. And I mean, it's a powerful tool that I guess that you could, like, I mean, it's not trivial to use and implement, but sort of the need of this tool is very obvious. And yeah, I don't know, like, I don't really know what else to add, other than maybe like going into different ways that you envision using it. But if there's no more questions, I mean, this has been super informative. I don't know if we need to like keep the seminar going so far. Son, do you have any like thoughts and things you'd like to share?
So, I mean, going forward, definitely runtime migrations are the most tricky things to test. I know there are lots of tools that we currently use to test these things, fork off Substrate, I think try runtime as well. So I'm just trying to show here that like Simnode can do better than these existing tools, because you have, unrestricted access to your state. You can create as many blocks as you want. You can also simulate transactions from any accounts that you want. So to me, Simnode is a more comprehensive system for really, really poking your runtime from any angle possible. I should mention, you can actually also revert blocks, sort of just so you can execute two different transactions at the specific block height, to helping you simulate, test properly. You can be more confident in the runtime that you're pushing out and releasing to the public.
Super cool. Well, thanks so much for coming on seminar to demo this and kind of go through everything. I'm sure it'll be super useful for other teams, and it's definitely, again, like, this is like a very important part of becoming a parachain. You need to write tests, you need to test in different environments, and Simnode is a great tool to sort of equip you with what you'd need.
Yeah. So thank you guys for having me. This has been really great. I look forward to seeing PRs at the Simnode library. Bending it to your tests and bending it to your purposes.
Definitely, yeah. Let's try to build that library together.
Exactly.
Okay, thanks so much, man. You have a great day, and thank you everyone for watching. We will post this video on this channel, and also it's available on YouTube for those that want to watch it on YouTube. So all the best. Cheers.